Welcome back. In a previous episode, we were building an LM317 based voltage regulator that's designed to take 12 volts and bring it down to 5 volts for an automobile. Unfortunately, at the end of the video, we were unable to do so because there was just some issues with the board. And at the end of the day, it just ended up being a layout issue. So I took some time to diagnose it and perhaps build another one. And in reality, I should have just stuck with the 7805 regulator, which is already set to do 5 volts. I'm just using the LM317 because I just happen to have a whole bunch of them, as you can see here. I intended to use these to, well, build many things, and since they're so cheap, I figured let's get a bunch of them just in case. And when I ordered that, I got a bunch of the 7812s for 12 volt and 7805s for 5 volt. And well, I've just basically gone through all my stock of those. I think I have a 7812 or two left in here. So what I did was, between now and the last video, was I tried to diagnose the board, and unfortunately I still can't get this thing to provide the proper voltage. So womp womp, fail, and that's horrible for me. But I still wanted to redeem myself. But what I ended up trying to do was, the way I had the resistors oriented before just didn't look right, and I didn't really have the proper output rail and the resistors tied into the right spot. So I tried to redo the wiring here. So you can see this is the input side for the positive. It goes through here where normally there'd be a fuse. We just have a little jumper in its place just for testing purposes. It comes through the little capacitor here for filtering, and then it would come through this red wire here through the very last tab, and that's the input. Then the next one here is output, and that actually, from the other side of the board over here, connects over to the next capacitor for filtering. And you can actually see there's a lead running around the outside edge over here. That's the negative side, the ground. So that's where that's connected to there on the other side. And what I did was, since that's the whole output rail, I brought another red wire over here to output to the USB. And then where the last one is the adjust, you're supposed to put resistor 1 between that pin and the output pin. So instead of trying to cram everything over here, I just bodged it in from here around over there. And then you need another resistor, R2, between the positive rail and ground. And well, the easiest place was just to put that over here. And while these values worked on the breadboard, when we tested it out, when we put it in the circuit, it didn't give us the right voltage. And well, again, it's not giving us the right voltage. And I'm afraid to put any kind of a load on it because the one load I'm trying to use is a cell phone, and I don't want to plug this in and overvolt the cell phone and blow my battery out just to try to get the voltage down. And I don't think that's the case. So I have to go back to the breadboard ultimately, but you know what? I really wanted to get this project finished. So if you look in the background, you can see here's the one that's LM, or I should say the 7805 base. This is not the LM317. So this is just taking 12 volts and it's bringing it right down to 5 on its own. I did use the heatsink from this original one since I only have the one left. And this heatsink is actually not big enough for the amount of heat that's dissipated. I'll have to get the infrared gun out and we could just get a quick reading on it to see. In fact, it was actually warm enough before when I was testing out charging my phone that I actually needed to put a little fan on the desk here to keep it cool because it was quite warm. It was getting kind of hard to touch it. And somebody commented, actually one of my longtime subscribers and actual donor to the show, but he commented saying, you know, you can't beat these step down DC to DC voltage regulators because, well, they're IC controlled, they're switched mode, they have a little inductor, and like I mentioned before, there's an IC chip in here and a couple other little pieces. But I know I can make this a lot smaller, especially with surface mount components. But given the size of the heatsink you need to dissipate the amount of heat that's, you know, wasted in this thing, basically, that you don't have to do in this. Yeah, the inductor gets a little warm, but not hot to the touch. And I've used this to charge my phone many a time, and it's worked flawlessly. And I plugged this in, and it worked. In fact, I used one of these charge doctors here, and noticed that my cell phone was drawing about 40 milliamps, I think it was. I'll have to rerun the test and see. It would look like it was around 40 milliamps. And that was just because I was on a low charge. I didn't really need to put too much into it. I'm sure if the battery was dead, it would maybe draw more current from this. Not 100% sure. I did put 2 LEDs on this. One of these is actually hooked directly to the 5-volt output, which would be the green one, let you know USB is okay. And then the orange one, or it lights orange, but it's really supposed to be yellow. That one there is hooked up to the 12-volt side of things, so you know you have power coming in. So if one of these is dead, if one's dead, it would be the green one, and if both dead, you know there's no power coming in. It's pretty simple. And that's of course on the fuse side, so if the fuse is blown, they'll both be dead too. You can actually wire this if you want, so when you have power coming into the terminal, this would light. And if the fuse is blown or if the regulator is blown, the green one will not light. But that's pretty interesting. But yeah, the amount of heat this thing puts out is definitely, you know, you're going to need some kind of good ventilation for it. You're not going to want to put it in a project box or anything like that unless you have a little mini fan in there, because it's definitely going to get pretty warm. But I'm going to just reorient things and we'll power it up and I'll show you what I mean. And now looking at this setup, we can actually see it's not drawing 40 milliamps, it's 410 milliamps. Yeah, the scaling on that is a little hard to read sometimes, but it is actually dead on 5 volts charging my cell phone, which is just slightly off camera here. But I'm just going to grab the infrared and we're going to see how warm that actual heatsink's getting. Yeah, that's 133 degrees F, so that is quite warm. And you know, depending on where I hit it with the laser here, we could see. Maybe if I get right up on 117, 135, yeah, that's dead right in the middle there. So that's really warm. So you know, you're definitely going to want a little fan or a bigger heatsink of some sort for sure, because that's quite hot. Now conversely, we can take a look at the other module and see it runs much cooler, and that's definitely a more desirable effect, obviously, because you don't have to worry about that wasted heat. So that's what makes this more efficient. It also has a wider range of input voltages, and even with the higher input, yeah, it's still going to get warm, but definitely not as warm as what's seen with the linear regulator for sure. And like I mentioned, the greater the difference between input and output voltages, the greater difference in the amount of heat you're going to get. You know, at this rate, messing around with all these different things, in all honesty, for the amount of work it took me to put this together and for the cost of what this is, you're better off buying these. Just, you know what, and if you place an order for one, get a few, because they're very, very handy. You can use them in so many different situations. You can even take a couple batteries, you know, as long as they're 12 volts, or actually I think it's 6.5 volts up to, I believe, 40. I'll put that in the description and also put a link to where you can get it and everything else. And in the last video I put a little diagram, actually just a list of all the parts needed to build this. I'll do the same thing for the other one as well. You know, it's a fun little thing to solder together, and yeah, it does serve a purpose, but you know, efficiency wise, time to build, cost of parts, I'm going to make an argument to just go out and buy the module. And that's what electronics has become nowadays. It seems like everything's a module. Everything's just a little thing you can buy and just wire it into something else and put them all together in a little box. And you know, if in the case of like the Arduino or the Raspberry Pi, you just add a little bit of code and that's it, your project's done. And you know, I guess it's evolved. That's a good thing that everything's like that now. It simplifies stuff in a way. You don't have to actually worry about building these things. But in the same token, it kind of takes a lot away, because, well, here I am stumbling to build these things, and you know, I really want to know all of it. Here's a quick thing of what I mean. We did a video on Raspberry Pis before. I got this box from work. It had some little treats in it, and I said, ooh, that would be a cool thing to build a Raspberry Pi into. So sneak peek, here's some components. The Pi itself, you know, we mentioned this. There was a USB hub and Ethernet connection, a bunch of different things here, a little power supply. And this is going to be a little computer when it's done. And I mentioned that we would do something before, but I said a plastic box. Wood's going to be the way to go, I believe. It looks a lot nicer. just figuring out, you know, where we're going to mark these and how we're going to cut it and the whole 9 yards for the inputs and outputs. But that's the idea. I didn't really necessarily have to build anything in here. Maybe a little modding, maybe a little soldering, but definitely nothing built. Everything that, well, there's going to be some stuff that we will have to custom make, but definitely not to the scale of what's in here. And another thing we'll talk about definitely in another video, but I have one of those old electronics project labs from like Radio Shack with all the different components in it. You can just follow a schematic and build the final thing. It's all analog, you know, and nowadays if you find one of those, it's, you know, got some digital elements to it, or, you know, stuff like these modules where, like I said, they snap together, or, hey, you know, like the Arduino and the Pi are so prevalent nowadays. That's what people are messing with. And it's like I said, it's cool, but, you know, I like this kind of stuff a little bit too. Anyway, guys, that's all I really have for this video. I want to thank you for watching. Hey, we reached that 1,000 subscriber mark. In fact, we're getting pretty far past it. I'm almost 20-something subscriptions past that, if I remember correctly from when I looked at it. And I just reached the 1K mark just the other day. So, you know, you guys are signing up pretty quickly, and that's awesome. And keep coming back. We'll have some great content. See you next video.